we'll go ahead and start. At least this one I can see a screen to see what's on the screen. If Dalton appears turned around the other way, and so if I'm sitting here, I can see what's on there to know it's what it's recording. And with the angle and the way the space they got there, I looked at the video the other day, a lot of it's the backside of the image, but it's what I took pictures of. All right. So this week will be number systems. Let's see where we get to today on it, and then we'll finish it first. I did it completely in 1 hour, less than 1 hour on the online class yesterday, their collaborative session. So I didn't give them many examples. I only gave them an example of each one of each, what essentially did. So we'll spend a little more time on it in here. Your next test isn't until we get to chapter module 7. So that should be week after next, if I remember how it's scheduled is. Okay? We're basically doing a module a week now. I have not graded anything. Permission slips have not been entered out there, so I've had several people writing and posting things out there of, have I got the permission slips? Have I got the permission slips? They're still exactly like they came. And probably there's a pile of them over in the egg. I don't think anyone has gone to get the mail for our office over here since I went over there. And I had stopped to go over there to check them. I do have, which doesn't really affect y'all in here, but could affect you here in 2601. I have started hosting Collaborate grades for last week and this week, and I was doing that for a while. So I am making some progress on that. But it just seems like it's been nonstop, so I just haven't gotten to grading yet. I'm trying to get to doing grading. So that I just don't have, it doesn't look like there's any time that's scheduled for doing such thing. So yesterday I spent all day doing collaborate sessions with the online classes and answering emails. Sunday night I was answering emails. Last night I was answering emails too. So from 9 to 3 o'clock yesterday I was on collaborative sessions. And then literally the one for 2451 ran an hour. I cut it off at 2 minutes till whatever the end of that session was, whatever time we started from. Did a real quick wrap in about 2 minutes and cut it off at 2 minutes till finishing the last couple of things. And one of the other classes ran a full hour the same way. So those were full during those times. And lunch, I went up to High Singers and got lunch yesterday, and that took a little longer than I thought it would. But I had a voucher from them for lunch for January, because my birthday was this month. And it expires the end of this week, so yesterday was about the only time. Yesterday or tomorrow, and I've also got from Firehouse Subs, I've got a thing from them that's got to be used this week, because we get on their birthday club, you get a bingo sub for free, but it's good from their birthday for the next 6 days. So that had to be used this week too. And I was going, that's gonna take a little longer just to drive up 4-0 to get to lunch, to get there versus Icelanders. So I gotta go to Icelanders yesterday because Wednesday, there's a little more flex in the schedule. So I squeezed that in there, and that took a little bit longer. Although it's 750 value, and when I would check out, I figured I'd owe them $1 or something, and was looked at me and said, "It's free." So I gave a great tip and went on my way. So I did those, and those all took, and then at a chamber event at 4 o'clock, I'm going to post a picture from that one. Here's my intention. General discussion. Y'all see a picture of us recognizing the group we tested, which was a travel agency. We had fun. And then when I left there, I went over to the Ringgold campus, sat there and worked for 2 hours. And then I had to go to the city council meeting for leadership. Catoosa last night for the school was to do leadership. Catoosa, one of the requirements of the leadership class is I had to go to both city councils in Catoosa County. And they're on Monday nights, and I did 4-0 2 weeks ago. And so I did Ringgold last night.
Were you there when the police officer resigned?
Mm-hmm.
Yeah. Heard about that this morning.
Because his resignation speech was probably about 15 minutes long. But we must have had probably 6 or 7 pages written. He basically chewed out the city council diplomatically. He telling them what they've been doing wrong, hadn't done, and then compliment them on what they had.
They did compliment them some? Okay, yeah.
Yeah. Because he told them we've made progress in 10 years. So he had been police chief. But then he was going, but we don't have stuff we need. And they got some more stuff now, and then their police cars are all out of date.
And I thought they had newer ones now than they had. They still
newer ones than they had 10 years ago, which is what he reported.
Yeah.
Because he said when he started, they only had 2 cars, I think it was. Mm-hmm. And now they've got 6 or 7 cars. Yeah. But all of the police cars in Ringgold are 2010 or older.
See, I live in Ringgold, that's where I live. I live in
okay. So they are old cars. Because for a police car, that's an old car. And actually, part of them, he said, they had gotten from another agency and used. So they were worn for the other agency, but they were still good where they could use them for a few more years, but they're beyond their life. So he didn't give mileage numbers on them, but I suspect they're very high mileage. And the other part is a police car, especially a city police car like that, even if it's got less than 100,000 miles on it, it's got a bunch of miles because it's all local, stop and go going. Versus my car up there in the parking lot that is 19 years old and got 756,000 miles on it. That it's not as worn as those cars, because a lot of my mileage has been on the interstate. And that doesn't wear a car as bad as when you stop and go all the time. Yeah, I've done a lot of interstate driving. So it was interesting on that one. I reported on that. And then they also, the expert they had hired to study the fact of the flood last summer in downtown gave his report last night too.
So it's just bad news all around?
So that was mixed in there. So that lasted about an hour. It started 7. I think we were out in an hour. Both those occurred because first they had his name, whatever the attorney there. think it's
The
from,
crack and posting?
yeah.
Yeah.
He got up and spoke at the beginning about the water report, and he went for a few minutes on it. He stayed within it. I think he got 5 minutes to speak to him. But they suspended the rules when the police chief was talking for him to do his whole spiel. And then they suspended for 1 or 2 other that gave a talk to or something that they were giving everyone a chance to speak. But it was weird when the police chief was speaking. I hadn't looked behind me, and I was sitting on the back row, and I hadn't noticed or anything. So I walked in and sat down, and I said, "Well, I'm going to leave." He said, "Class with me." And we had talked a little, and then they came in and had a work session before an individual work session, which would give you more information. That wasn't what I was needing. I was in y'all's shoes last night on it, and I was just there to get my credit. Although I was there to learn some information. Okay? Because that was for my class. And when the police chief started talking, and as he was talking along, he said something about recognizing all of those in the back. I went, what? I looked around, and the whole police department is standing across the back wall. And 1 or 2 other former officers standing there, that they were all standing there in support of you across there. And I didn't realize we had about 10 officers all standing behind us till that point. That was a little odd. So, it has been on the go. But now we're on number systems. So, first thing is, in the Blackboard materials, I have videos from when I've taught number systems before back in the past that are ones were recorded back in the early 2000s. Number systems have not changed. I heard y'all talking about math classes and stuff. They're still basically the same thing as they've always been. Okay? So if you listen to the videos, you're going to get basically the same thing I'm going to tell you here. So it's going to be a little different, obviously. It's like you move from talking to right there with the class. Likewise, you don't have the video yet from yesterday's Collaborate session, but you will have that one. I meant to post it into y'all's class. Also, the other one last night, and I put it into the online, and I forgot to copy it, and I saw that just right in here. No, took my time to do that. So, and it's going to go in that video recordings link that I've added down there. And I've got to get all of the Collaborate stuff moved into those. Another item that I got added onto, I got told about that to put them on YouTube and then put the link into somewhere in there. Instead of students going to recordings and Collaborate, because Collaborate does not close caption stuff. To be ADA compliant, I've got to do that. Blackboard's supposed to be ADA compliant, but Collaborate doesn't do any of that. So I've got all of those to do also. And that takes a little bit of time because I got to download all of those different videos and then upload them to YouTube and then stick them into the classes, which will work, but that does take a little bit of time. And time has gotten short. And so there also is a handout in there where I've got materials or something in Blackboard in your module 5 that if you look in there, there's no assignment to do this week, okay? But there is, if you click on the folder, you'll see there's something else in there, and that's got the videos and that's got a handout. The handout's what I want to mention to you, and I'm actually going to be talking basically from it because it's written basically on this lecture. It's a book that I've written, short little book. It's got 3 chapters to it or whatever. It needs another 2 chapters written on it, but I haven't had a chance to. It shows and tells you how to convert from binary to decimal and decimal to binary. I need to add hex to it also, okay? Also gives a history on numbers also. It's PDF file in there. It is there, y'all can download it. It also sits on my website on my articles page where people can download it for free. And then for those that just don't like getting anything free, I also have it out at the Nook for sale for either 99 cents or $2.99. I don't remember which. I keep intending to put it on Amazon, but then I'll lost the Word document file of it. I've got the PDF, obviously. And I think I've got it converted back to Word now. So I can do it again and put it out on Amazon, but I haven't done that. I don't know why. Might as well, I got all the spare time sitting around not doing anything, why I could get it posted out there. And I'll put it out there too. I actually do get people that buy it at Nook, even though it's sitting there free on my website. Okay, and that I've told people on it, like other instructors and stuff, and told them they can pull it down and use it in their classes if they want. So I've actually had some instructors ask me, can I use it in my class? And I'm like, yeah. You know, get it from my website, and you can just tell your students to go there and download it, and it's free. So there's a write-up on it if you're then go, wait a minute, I'm a little confused after the lecture or whatever, okay? But number systems are critical in the computer field, and particularly for you in networking and then for cyber also because of it coming off the network, okay? So number systems, there's lots of them out there. There's an unlimited number of systems. We're only worried about 3 number systems in here. It's not the only number systems that people will work with. Also with computers, you'll actually, if you talk to people that have been in the business of computers longer, they may tell you you need to know another number system that you really don't. At least that's my opinion. Is they'll throw in octal also with you, but octal's not used today. It was used by early mainframe computers, some, but that goes back really far back. Okay? But you've got some people that I think they learned it when they were in college. They got told they had to learn it, so they think you got to know it too. You don't even know all of it. But what I'm going to teach you about number systems, it doesn't care. Because once you see what I'm going to teach you, whatever number system you find that you're confronted with at some point in time, you'll be able to work with it, okay? Because they all work the same. There's a basic off of them all. Most of the time when you're talking about number systems, they throw you each one separately and you don't see that there's something common between them. So hopefully y'all catch that as I go to tell you that. But the first thing is I want you to think about is we're going to talk about the decimal numbers first, but before we do, I want you to think a little bit further, okay? That decimal is the number system we use. There's 10 single digits in it, and that's the one that you're all used to using. That's what you've learned from the time you started, after you were born to now, okay? And that's the one that's used worldwide today. However, the decimal number system is not the only number system that humans have ever used. So that's the big part I want you to catch right here. It's not, this little bit's not going to be on a test or anything, but just for you to realize humans haven't always used decimal number system. But why would we use a decimal number system before I throw you another system humans have used? Why do we come up with a number system that has 10 single-digit numbers to it.
Why are we going with a decimal or why do we use a decimal system?
Why are we using a decimal number system, which is 10 single-digit numbers? Yep, right there. That more than likely we developed it off our fingers. You know, that people from way back before we went into writing down numbers or whatever, were doing just like y'all did when you were little kids, and some of you maybe still do it today, that you counted on your fingers, right? And when you ran out of fingers, now you make a mark on a piece of paper, okay? Or you may take off your shoe and wiggle a toe or whatever, okay? Back then, they probably made a mark on the ground, okay? They reached over and marked on the ground when they ran out of fingers, and counted again, and so on, okay? So we ended up going decimal, primarily for that reason. Now, for the same reason on it, there was a base 5 number system some civilizations used. For some reason, we got 5 fingers on my hand and 5 toes on my foot. And so that was used a little bit, but not too much, although I believe it was the Greeks used it a little bit. Okay? But that didn't have much, didn't really impact anything on it. That then we ultimately settled towards base 2. But the Babylonians, back there in somewhere probably 3,000, 4,000 BC or BCE, whichever letter you will use. Somewhere back in there. And I believe it's the Mayans over in the Americas. I think it was the Mayans and not the Aztecs. Okay? But one of those groups, and I'm pretty sure it's the Mayans, or used a base. They both used a base 60 number system. Now they came to it a different way to do it. And it doesn't make a whole lot of sense to me still, that I have found out how they came up with it. I still can't quite add it all up, although I've seen drawings that showed it, was they were counting all of your joints, coming up with stuff. So when they counted, they were counting that they counted off the joints on all your fingers, joints coming on across your hand, and other joints on you to come all up with it, and ended up they were counting 60 different things so far. They had 60 single-digit numbers in the system. It was a base 60 number system. Okay? As far as what the Mayans did with it, not a whole lot that, not really anything that affects us today from it, but that was what they were operating on here in the Americas. And it was 2 groups that separately came up with the system, okay? Because obviously the Mayans and Babylonians weren't exactly talking with each other. There was this little pond sitting between the 2 of them, to use the British term. Okay? So, but the Babylonians, that does affect you today. Because people in Babylonia, and Babylonia is basically where Iraq is today, okay? So Iraq is sitting where Babylonia was, okay? There in Babylonia, those people were very advanced in mathematics and some scientific type stuff. And I mean advanced for their time, okay? They measured looking at shadows in whales and the angle of the sun. They figured out what the circumference of the earth was and had it real close, okay? Just doing geometry. They came up with geometry, okay? They developed a lot of your trig stuff. They developed our timekeeping system. Now, think back when you learned how to tell time. I don't know about y'all, but I know for me, it was confusing trying to learn to tell time, because how many minutes are there in an hour? 60, right? Not 100, and we were learning to count at the same time, and everything else we were learning to count that you count up to 99, and then you went on to the next bigger number that had another digit to it, okay? So went to 9 and the same thing. Clock, you went to 59, and then it started over. And that was confusing to me, I remember, okay? And trying to learn that about 60 on that versus what made sense everywhere else. Everything else was 100, okay? 60 minutes in an hour. How many seconds in a minute? 60. Okay. How many days in a year?
365.
360 approximately. Okay. 365 most years, except this year we got 366.
What was it, leap year?
Saturday, February the 29th occurs next month. Okay. So, and there's 24 hours in a day. Okay. Now think about all of those numbers we just said. They've all got something to do with 60 or 6. Okay. Because even the 24 hours in a day, that's a 6.
But there's 7 days a week.
Huh?
But then there's 7 days a week.
There's 7 days a week. Yeah.
That's crazy.
But they didn't do that part. That's more, probably a lot of that's off in the Bible, where we got the 7 days in a week approach. But 60. How many degrees are in a circle?
And how are you reading the circle?
How many degrees are in a circle?
361.
360. Okay? Because if it's a right angle,
It's 90.
90. Okay? But there's not 100 degrees or 1,000 degrees in a circle. 360. Again, off 60. It was the Babylonians came up with all of that. They started the timekeeping and came up with a clock on it. They actually, sundials was a development of theirs. Okay? They didn't have a nice clock back there or a nice little digital one, so a lot of you all like an analog one. It's a digital one, but this place analog. But they came up with those. They developed the geometry, so they were using a base 60 number system, so 360 degrees in a circle. If they'd been using a base 10 system, we'd probably be looking at that it was 1,000 degrees or 100 degrees in a circle. Y'all follow on that? Time, also, 60 minutes an hour because of the Babylonians. So that's what they came up with. Why'd they do 60 minutes an hour? Because that's how many single digit numbers they had. So 60 minutes made perfect sense to them. Does everybody follow on that? So you're impacted by some other number systems that humans have used in the past. Okay? And that it's not just decimal. Now, all of that part, you're not going to see on a test.
No.
That's all just information for you in order to make it a little more interesting. Okay? And gives you an idea of what. But decimal is what we use. And that's what you completely think in and operate. Okay? We're going to look at binary also. Binary is what computers use. Okay? That's what everything's stored in on. That's what they process in. So that's what's going on internally. It's in binary. Binary is a base 2 number system. Decimal is a base 10. It has 10 single digit numbers. Binary has 2 single digit numbers. All it has is zeros and ones. computers are electrical devices, right? So if you use binary to store stuff in them, and it can convert it and put it out in decimal or whatever characters for us. And it can take what we want, convert it and store it in there. But if it works internally in binary, makes it a whole lot more efficient and works better than if we try to do it in the other. Because if it's electrical, if we just have it in binary, it's easy to represent. Is the power on or is the power off? And I have to sit there and try to figure out how much is the power on or power off. Okay? Is it a magnetic charge there or not a magnetic charge there on your hard drives? Okay? Your CDs, DVDs. Has there been a hole burned there or not a hole burned there? Is it a pit or a lane? And I don't remember if ones burn holes and zeros don't burn holes, or it's vice versa. Okay? But it does one or the other. And that's standardized stuff. It's not something I've ever needed to remember of. Which it is on the on that type stuff. Okay? If we're sending it across the wire, if we send a signal or not send a signal. Okay? So is it a 1 or a 0? We don't have to worry about variances into it. Although, y'all saw at the end of the last module, it does do some variance on what type of encoding method it uses. Okay, but it's still using sharp lines to operate from. Everybody follow on that? And that's what you want. Because if we take that light switch, instead of it being an on-off switch, that's easy to represent in the computer. Either the lights are on, the lights are off. We change it and we put a variable on there. Okay? Which all of you have got probably somewhere, or you use them at times. Or like what I use at church, that I got a slider to control the lights in the church sanctuary. Okay? But if I tell y'all each of you to go turn the lights on 30%, are we going to get exactly the same amount of light turn on when each of you goes up there and turns that switch on? No, because you're not going to get exactly 30% on. Okay? Now, where we're doing it through IoT device with an IoT variable switch on it, yes, we can get that consistent because it sends and says an exact amount on it, and it's back to using it in the binary of what it's sent to. Okay? It says set that switch to exactly this amount. But you sitting there and trying to adjust on it, or if the computer was trying to store it in your side, getting it exactly right would be a whole nother matter. Okay? I'll see you on that. So, simple binary works real well for it. So we're going to use binary for that. So decimals for humans, binaries for the computer. Hexadecimal is the third one we're going to look at. That's Hexadecimal. Okay? That's a base 16 number system. It means it's got 16 single-digit numbers in it. Okay? That one's going to be used for us to be able to see exactly what is stored or what's sitting in the memory of the computer at any point, and that we'll be able to see exactly what it is in an easy-to-read format. Okay? So you'll see the other part is, and it's the same thing actually, but where you'll see it quite often is IT version 6 addresses are expressed in hexadecimal. Now they're actually 128 bits long. Okay? And instead of putting it out as 128 decimal binary numbers, we express it into hexadecimal, and we get it down to 32 hexadecimal numbers, which is a whole lot more easy to read, and you start reading 128 zeros and ones, you're going to mix them up. Okay? Likewise, if you need to know what was in the memory of that computer when something happened, From a cybersecurity viewpoint, looking at what was at a specific location. From a programming viewpoint, looking at what's at a location when your program bombed to figure out why did your program just blow up. Okay? So there's definite reasons to go in and look at exactly what was in the memory. But the spot you're worried about happens to show up on the 15th row and the 17th column on this page of tons of zeros and ones. Are you going to find the right number? No. The zeros and ones, if you're not sure if the zeros and ones are going to start going crazy on you, get on Facebook and look down where people post little things. Find the 7 in the whole chart of zeros, or find the 8 in the chart of all those zeros, and try to find it. Okay? You're looking at the same type of thing. Okay? Hexadecimal allows us to take 4 binary digits and express them as a single hex number. Okay? Which is going to be the advantage of it. So that's where we're going to use each of the number systems and why we're going to use them. Does everybody follow on that part? So there's a reason for you to learn all 3 of them. Okay? And there's obviously a need to be able to convert back and forth. MAC addresses are also expressed in hexadecimal. Okay? So you see things in hexadecimal. You've seen things in hex. You may not have realized it. And when we talk about hexadecimal, I'm going to tell you, just like I told you back when we were in module 2, and I told you that I was teaching you English, that your English teacher wouldn't like when I told you got to use no shut to start devices, just like Windows, you got to go to start, to shut down. And that no shut is not proper grammar, okay, because we're doing a double negative, which is a positive, which actually is true, and you're not supposed to use double negatives. It's what your English teachers have taught you all your life, okay? So, and here you're learning some things that are not exactly what you always like. So, what I want us to look at first is we're going to look at decimal. This is stuff you already know some of it. You may already know all of what I'm going to talk about right here. But I want you to look at how decimal works again. You may not have really thought about how it works, and you may not have ever got told why things are like they are. Okay? And then when we look at the other 2, you're going to see they work exactly the same way as decimal, and that it's not that different. And then if you ever work to some other number system, you can work with it no problem. So if somebody ever threes some odd thing to do, you can do it. I need a pen to work. So, we're going to start with decimal. We've got 10 single-digit numbers in it, so 0 through 9 exists. And then here's the important part that you need to get out. You definitely need to know that. I hope you already read that. Is we want to look at column values. Because you know that you've got the 1s, the 10s, the 100s, the 1000s. So, right? Yes. But where did those numbers come from? Okay? That part you may not know. Okay? This is 10 to the raised to the power of 0. This is 10 raised to the power of 1, 10 squared, and 10 cubed. Okay? Any number raised to the power of 0 is always 1. That's a mathematical fact. Okay? Any number raised to the power of 1 is always itself. Those 2 you may not have picked up somewhere all the way. Okay? 10 squared is 10 times 10. That one, all of you, I'm pretty sure, already know. And that you can tell me 10 times 10 for 10 squared is 100. If I'd asked y'all what 10 squared was, you all would have been able to answer that question. 10 cubed is just 10 times 10 times 10. Probably most of you can answer that one, but maybe not everyone. Okay? Now we went 10 to the fourth. That you go, wait a minute, I have no idea what 10 to the fourth is, but when we look at these columns going across, you know it's 10,000 anyway. Okay, but it's 10 times 10 times 10 times 10. It's 4 tens multiplied by each other. Each of these columns is increasing by 10 times the previous one. 10, our base. Okay? So follow the columns right here. Is everybody with me on remembering that part? And also learning where they came from. Okay? It's just the base number of the number system raised to power starting from 0 up. That's going to be an important piece of it. And us learning it from the system we know, it's not something different to you right there. It's a different look at it for most of you probably. But you learned back there in kindergarten, first grade about column values, and you were told they were 110, 100. But they didn't tell you this part. But you may have picked that up in some further math somewhere along the way. Or you may not have. I didn't. Okay, until I was in computer classes. So that just depends on the person. Binary. Is a base 2 number system. Okay? It only has zeros and ones. If you ever see a binary number with anything other than 0 or 1, it's wrong. And that could be a multiple choice question for you. Okay? To pick out the binary number. I've seen that actually on certification tests. And they don't give you a short word number like 10 or 100 or 101. They give you ones that are 7 or 8 characters long. They give you 4 of them, and you're supposed to either pick out the one that's really binary or the one that's not a binary number. And as long as you know, as long as zeros and ones, you can pick it out. You can figure out which one is your right answer. Okay? With the binary number system, it's going to work on the same as we just said right here. So the first column is 2 to the 0, then 2 to the 1, 2 squared, 2 to 4. And really, you're not have to worry about for here any further than 2 to the 7. I'll go ahead and just give you that. You could run into bigger than that, but normally you're not really going to, but you're doing computers. Because how many bits are in a byte?
32.
Huh?
32.
No. Huh?
Is it 64?
No.
Is it
How many?
24?
Not 24. Who's somebody else or another number up there? 8. Okay, there's 8 bits in a byte. You are going on words.
Oh,
Okay?
and
But there's 8 bits to a byte. And in 1 byte, what was normally always was it took 1 byte to store 1 character. Now today, because we've changed the encoding systems and we've moved to Unicode from EBCDIC and ASCII, it really takes 2 bytes to store a single character normally. Okay? That's because computers were originally America-concentric, English-concentric, and the encoding they came up with originally was for all Arabic letters. Okay? And so all they had to design for was 26 uppercase letters, 26 lowercase letters, and a bunch of special characters. And you could do that in one byte. Well, as it became international and you're putting other languages in which use other characters, and a lot of languages do use the same characters we do use, and maybe a couple of extra little ones, like Spanish throws on a few with accents and stuff on, but pretty much still the same letters we're used to. But throw Chinese into it. Their letters don't match our letters at all, and so you had to come up with all new coding, and they don't just have 26 letters. They got tons of letters. Okay? And so there wasn't space in there to get all of these other languages in there. And so you had to go to 2 bytes to represent it in instead of 1 byte. But essentially still think of a byte as what you can store 1 character. We'll still stay, it's still, the definition is still pretty well considered on that, although Unicode uses 2 bytes. Okay? It's just like on Unix, that, and all of those derivatives of Unix, that they've used date field. The date has been stored in 1 byte since they created Unix back in 1970. Actually, 1069, but they put it in usefulness starting 1st of 1970. They've always stored this, the way this date is actually stored in those systems is in the number of seconds since January the 1st, 1970. Don't you know that the Earth got created and everything occurred in 1970, right? That's what they taught in history, right? History doesn't go any further back before 1970, does it?
No.
If you're looking at it from the Unix history, no, it doesn't go, well, Unix really got developed in 1969, but they started their timekeeping on it from January 1st, 1970. Okay? Because actually Unix goes back to August of 69. Somehow they came up with, they counted time, they didn't start keeping track of time until 70. That's going to be a problem, because in there, in 1 byte, storing it in number of seconds since 1970, that comes through Y2K with no problem. They didn't have a Y2K problem on Unix systems. It was a problem on DOS Windows systems. And on, although it could be on the Unix systems if people stored their dates out there. If they stored it the way Unix wanted to store it, it was seconds since 1970, no problem on that date. But with most, you're actually sticking the date out there as month, day, year, or some format off of that, okay? If you're in Europe, it's year, month, day, and so on. And year, month, day actually works better for when you're trying to sort stuff around and everything. But if you're looking at normal American writing it down, month, day, year. Where in the world they came up with that order on it, I don't know. Whatever person was thinking about the videos. So you do have a problem that's going to occur in 2038. Because in 2038, and I think it's March of 2038, we're going to run out of seconds since January 1st, 1970. That's the maximum you can store it here. We're going to have run out of it. When you're looking at binary numbers stored in that single byte, we'll have more seconds than there's seconds that you can do since then, how big the number gets. So we're going to have a Y2K problem in 2038 if they don't fix it all up from now, okay? And it's known it's been coming. Now, they're doing some things more better on it and changing it to where so they do 2 bytes now instead of 1 byte on a lot of systems. But if they don't, at that point, there's going to be computers whatever date it is in March 2038. Same thing's going to happen as was feared, and it did happen some in 2000 with Y2K. Time of what you got stored out there, the date you got stored out there, go on it. After that point, suddenly comes this 1970, not 2038 that you're storing on. So you went back to 00, just like Y2K. The issue was that you were storing dates out there as 2-digit years. And you still see some out there. As long as you're not looking at stuff before 2000, that's okay. But you really shouldn't be. You should be putting this 4-digit years up there stored, And as you try to do calculations off of it, all of a sudden we got a problem. Because you were going to be talking, it being like it was that they were a number a lot bigger than now, okay? So if you were born in 2001 and it keeps it in 2-digit years, and they go to compare off of it, it's going to think that you didn't match with the way the other stuff was, okay? But somebody born in 99 was a negative 1 year old at that point instead of being the 1 year old. Okay, so it did weird things on it. It came up with wrong stuff. So it did give some problems, but it didn't give the major problems because people got stuff fixed. I worked as a Y2K programmer in 96, 97, fixing stuff. And fixed some more stuff after that. But this one is going to be the same issue again. And in the 1970s, I had instructors telling me in my computer classes that Y2K was going to occur in 2000, and the problems it's going to be if we didn't change how we wrote programs. People and everything back then said, oh, we don't need to worry about it because programs don't last. So they did. And we did have an issue. And then people didn't change their style until we got to just a few years from 2000. But it turned out it wasn't a big thing.
So like January 1st of 2038.
It'll be March something of 2038. We'll run out of seconds in there, and at that point, the next second, instead of it storing, it will have stored it all as ones across there, okay, in binary. The next one will store as 7 zeros and a 1. And obviously, this date comes before this date, but in reality, it should be this date. There's 1 second after that. Y'all follow on that? But this is back to 1 second after January 1st, 1970. This is 2038. And you can see where all of your calculations just went crazy. Anything calculated off date. Like figuring out when people's lungs are due. Okay? Which was a problem with Y2K. That did appear at times. People got some strange lung notices, etc. And on it. All right, so just be aware on that one. That is coming. And if you read my articles page, you'll see I've written several articles on that. And there you can find exactly what the date is, March, whatever, 2038. I don't carry that number around my head. All right, so here, you're normally only going to have to work with a byte's worth, although you could be bigger when we look at subnetting and stuff. It could go bigger, but normally you don't ever have to. Okay? So this is going to be 2 to the power of 0. What's that number?
2.
0.
Huh?
0.
No.
It's 2. 1.
1.
Okay.
What did I tell you the rule was?
Always 0 and 1s.
Any number raised to the power of 0 is always 1.
Oh, that's right.
I distracted y'all. I talked about 2038. 2 raised to the power of 1. What number is that?
0.
2. I also told you any number raised to the power of 1 is always itself. Because remember, when you're raising the power, you're really talking about how many of the numbers you're multiplying by each other. But if you only got one of them, it's got to be itself. Okay? You just got 2, not 2 times 2 again or whatever. Only got 1, 2. Okay? The 0 one's the one that can be a little confusing on it because it comes up to the value of 1 always. Okay? But the rest of them all fall. 2 raised to the power of 2 is what? That's 2 squared. 4. 2 raised to the power of 3. 8. Now, notice what's happening on these numbers.
Multiplying by 2.
Multiplying by 2 or doubling, okay? So you can work the rest of them out without having to sit there and multiply them all out, and that's where the cases are. Unless you're from a mathematical side, which most of the students we get in computers here at college are not mathematical. They're business, wanting to do computers business way instead of mathematical. If I was teaching this down at Georgia Tech, I'd have a different group of students. Okay? Because they're coming from a mathematical viewpoint for research and development of computers and everything, and not looking from it from business side. So they got to know math with it. So the next column is the 16s. This is supposed to be just a column. Now that we're getting 2 digits, I'm shifting them sideways to sort of show that. And then the 32s, the 64s, and the 128s. Okay? Now, so that's where those numbers come from, okay? And that's your values of your columns. When we start doing the conversions, it comes into play. You gotta know what column names are of your columns in each number system. You'll see how that related back to what you already know.
Yeah.
Most of the time when they go to teach binary, they don't tell you this part. And you're sitting there going, where did they come up with 1, 2, 4, 8 across there? And how do I remember that? Hopefully, you see the 2 of them makes it easier for you to remember. Because you know this one, you know this one. Okay? Now, let's do hex. Okay. Hexadecimal is base 16. And I'm just where we're going to get to today is we're just going to talk about the number system. Thursday, we'll go through the conversions. Okay. With hexadecimal, it's going to use 0 through 9. But now we've got a problem. You need 16 single-digit numbers. And all y'all know is 10. 0 through 9. Right? So, what mathematics does, and I'm following mathematically on this, is they start using letters. So, what you got told in kindergarten and first grade, again, isn't necessarily always true. Because those teachers told you back then, numbers are numbers, and letters are letters, and don't mix them up. Okay?
That is not true.
Well, y'all are all grown up now, so I can mix it up in your brain. So now, letters can be numbers. Okay? And normally expressed as uppercase letters, but I think you could use either. and you can go either one, but normally people always write this out for case letters. So I really think it does go to lower case ones when you get into large number systems that you can do upper and lower. Okay? Because if you had a number system that had more than 36 characters in it, what you actually go to then is you use Greek letters, alpha, beta, whatever the others are.
Beta.
That, I know alpha and beta and what is it, zeta is the last letter. And I don't know the rest of them in there, okay? There's epsilon in there, there's all kinds of other stuff in there. But, so they go to those, and then there's actually a mathematical setup of what you use for symbols on all the different number systems, okay? What the Babylonians did, they had some different looking symbols for every one of those for their basics. They didn't follow our models today, but that's what they come up with. Stranger than things, I don't know how in the world they get straight on. Okay? The hexadecimal uses numbers plus the letters A through F. Somebody follow on that? So what would be 10 for us is going to be an A and hexadecimal. A B will be 11, a C 12, and so on. Okay? So you're going to, now when you look at that MAC address on your device or the IP version 6 address, you know what in the world those A's, B's, C's, D's, E's, and F's are sitting in there. They're going, that's supposed to be a number, and I thought Dr. Watt inferred these were numbers. Yeah, it is a number. Those letters are numbers. So now with base 16, we're going to have 16 to the 0, 16 to the 1, 16 squared, and we're not going to worry about any further than that. You'll see the reason in just a second. Okay? Actually, I'll tell you what the next one is, and I can give you the round number for the following one, but don't even ask me any further than that. Okay? We can sit there and calculate it out. So, use your thinking caps. 16 to the power of 0 is what? 1. We've done it 3 times now, so hopefully y'all got that one down. Okay? 16 to the power of 1 is what? 16. So that's the 16s column. 16 squared is what?
256.
256. And if you want to go on to 16 cubed, it's 4,096. And then the next one is 64,000 something. 234 or 232, I think. Was it wrong?
I haven't looked it up.
Okay.
I'm taking your word for it.
Okay? But y'all really don't have to worry about normally really beyond the first 2. Because what did I tell you a while ago when we first started talking in the lecture about why we're using hexadecimal? We can represent with a single hexadecimal character a half of a byte. But we said 2 hexadecimal characters can represent 1 byte, which is backward to here, which is our base way of looking at anything of how it's all stored in the computer. Okay? Now some things overrun those and look around that, but basically everything's stored in terms of bits and bytes.
So say that part again.
Huh?
You say that part again, you can store.
So in 1 byte,
Uh-huh.
that right there, we can store that
It has.
right there. Okay? And actually, we don't need to worry about that. Really, what we'll worry about is we can store that and that, and we're only going to be worrying about what's in each half byte, so we only worry about one single digit hexadecimal character for a lot of stuff. Okay? So pretty much we're not gonna, but we're gonna work with 2-digit ones. Okay? But you're not gonna have to worry any further with that one. You could see stuff later on, somewhere along the way up here a little further, but you notice I don't know what that fourth position, I know what the fourth position is, but I don't know what the fifth position is. Okay, I can give you an approximate number, and I have no idea what the next one is, but it gets astronomical. Because they go through the roof rapidly. Because you're multiplying by 16 each time.
It's over 1 million.
Mm-hmm. Okay? And you're not, all you're having to worry about is you're using this as just a way to look at what's in bytes in the machine. So you're only looking at where you're converting a half of a byte to a hexadecimal character. Okay? So for most of it, you're really not looking at more than this, but you're definitely going to need to know this. Okay? And so we're going to look at how to convert numbers from one to the other, and back and forth in every other direction around. But the part today was, what are the 3 number systems? And what makes each of them up? Now, what we'll do on Thursday is we'll go through and see how they all work together. How we convert from one system to the other. We're going to need to be able to do that. The computer is going to do that all the time for us, inconspicuous. But you need to know what's going on there. So you can see exactly what is really stored in the computer. Because you want to know exactly what it is there. But when it does a conversion on it, sometimes the code doesn't exist and it gives you something a little bit different, showing what's there, and that doesn't tell you what's really there. Or it gives you an unknown character or some strange. A lot of times it gives you that square little block. If you've ever looked at, when you looked at some dumps and stuff, you see lots of little squares like that showing all over the place on it.
Yeah.
What that is what was stored in that position, in that byte. There's no encode. It doesn't have on the chart of the encoding from Unicode, we don't have every combination in bytes written up at this point. We've got lots of spaces where we can add more things later. Because what? There's other symbols are going to appear. Symbols that we may use or come up with, that people do invent symbols still. To stand for instance, just for a smiley face. That can be out there and a heart or whatever. Those are actually sitting in there, okay? And there's more of those sometimes that come up with, so we need extra spaces on them. The other one is, we may not have all of the languages of the world accounted for at this point. It's like that. When that Martian starts talking to us tomorrow and we want to get it into his language or her language too, we kind of allow their characters. But Martian keeps looking in the window back there watching the structure to figure out how these computers that people are using on Earth work. Y'all haven't seen them back there up and down?
I see them all the time.
That's who I've been talking to the whole time. I didn't realize there was a group of y'all in here. So, if that was the symbol showing and you need to know, well, what was it? Because that would be a way for you to hide information out there sending stuff. So if you're a cyber person, you want to know exactly what was in there, because maybe they use where they're putting stuff in there, they're only using certain bits out of it. But they encode what they've put into whatever they're putting out there. They're not putting it in a full byte.
Yeah.
But they only put what they're putting in there using the first bit of each byte, and as long as you read that first bit of each byte, then you've got
So now what you're needing to find is the 8 characters coming down this way, which gives you the real character, instead of it being the 8 characters that way. Y'all follow on that?
And
Now, we haven't done anything really complicated. Or it's like putting words inside of a picture and sending across. And I just discovered this weekend when I was working with the cybersecurity team over there in Dalton, as they were in their semifinal competition, that all of a sudden it was pointed out, I think it was there. I think it was anything else. I think it was something else I watched. I'm convinced it was there that it was shown that I had been told about using fancy software to go and encode words inside pictures, and it's in picture, it doesn't show because in the picture. You can do it real simple. You open the picture up in Notepad and go in there and just type your little message in there, whatever, and that she's going to send it to me. So she's told me, look on this line in the picture, you'll find it. Yeah, it was the cybersecurity competition because one of their exercises was they got given a picture and they had to find the message in the picture. And they had no tools. If they wanted to find a tool to work with, they could, but they didn't tell them any certain tool to use or whatever. Turned out Notepad works. You open that picture up in Notepad, you're seeing it now close to what we're talking about here, but we're not seeing it in binary. And they had to look through the picture and see if they could find what the message was and answer your question with that message. Okay, y'all follow that? And you did it in Notepad, and anybody looking at that picture didn't know there was a hidden message in it. Open it up in Notepad, there was the message. Because actually they didn't hide it in there, that didn't do a hiding job at all. It was the tail end of the picture they set the words on. And they went and started looking and suddenly, well, wait a minute, I can read what's at the bottom, and jumped on down there, and probably there was a bunch of students at places that were all trying to look through all of that garbage everywhere, which is what it looks like. And then, if they stuck with it long enough, saw the message, have a good day or something, that was the last little thing of it. And that's how terrorists will communicate with each other. Cyber criminals will communicate with each other, drug gangs, etc. Because they can do it sending pictures back and forth. Because I can send her a picture of him, which is perfectly fine to everybody on it, but she knows, open that picture up in Notepad, and that a certain spot in that picture, I've got the note for her telling her who it is I want her to shoot and take out tonight. Okay? It's got nothing to do with him, it's just I used his picture for us to send back and forth. It was unfortunate it was you on the back road that she's supposed to take out.
make it quick.
Okay? Y'all follow on
I'll
that?
never see.
Now, y'all see where what we're talking about right here is useful for all of y'all. Okay? And you can actually use what I just told you to communicate back and forth with your friends secretly at times or whatever too. It's something you can just use yourself. Okay? It's not just used by people for criminal purposes. It can be used for other purposes too. Because I could be sending messages to y'all that we didn't want others to easily see, but be perfectly honest, above board messages. But we just don't need them to be out there. We don't want people to right off see what we're saying. Okay, so it can be used for bad purposes or good purposes. All right, question on all of that? Because it is 11 o'clock, or almost there, actually. I just misread the hands back there. Because that clock is an hour off, so we got 6 minutes to do it.
Can't they do that with, code and stuff too? Like, if you open, when you're opening a picture, they can attach code to it, that'll mess up stuff in your computer.
Because then that type of thing is what they're doing. Because they can stick it into there and then have something that looks at it and grabs it. So you can do all kinds of stuff with it. And if you just put it, now in the case of the one I just told you, what they had done, where you did a notepad, you're actually overwriting the section. You use the fancy little programs to it. It's doing it like this. And guess what? It's only throwing a fraction off on any of the colors in that whole area of the picture right here. So everybody sees it. But for this to work, either you got to put it in binary or you got to have the same conversion program that the person put it in there with. Which one of them is called Blue something that I learned way back. And I can't remember the name of it exactly. And there's several all out there that are public programs. And I'm sure the dark web's got a bunch of others.
You can use this to steal people's information too.
Hmm.
Could you use this to steal people's information if you wanted to?
The what?
To steal their information.
I missed something on
Like their credentials or whatever? Could you use it to do that?
that. Maybe. Not sure. But you can do all kinds of stuff with it. All right. Any other questions?
This is a while back when I was in high school. It was taught to me that they can use certain things like this to tamper with infrastructure, like as in one electrical system in a country. Is that possible?
Yeah. Because you're, again, wherever you're sending this to, you could be sending, and that you can find out ways to use it on. And that you could have, and then you can in turn embed inside something else, and not just pictures. Don't give us some music, videos. You could do it in a regular computer file, stick it inside a program, and have it maybe something else hidden in it that does stuff to it. So you can do all kinds of stuff to it.
That's not great.
It's purely up to the imagination of the people doing it.
Something so good, it could be so used for so much good, and
So,
turn around for
You
something
can do
bad.
some good with it, because after all, if you and I were working for the CIA, okay, and we're sitting over in some other country spying, whatever, legitimately, okay, get their information to protect us. It would be a whole lot better for us to communicate where they don't know we're even sending any communication other than we're tourists, because we're taking pictures that we're in Italy. So we go in and take pictures in Rome and in Venice and send those back and forth. Instead of being tourists, we're actually watching other stuff and sticking it inside the picture to send our information back to the future.
I was also wondering, could they use this as a form of security? Like you said, they can send information back.
Yeah, so you can, that's a way of securing that information, because now if you and I send that picture back and forth with each other, that looks like it's just a touristy picture, and we put that message inside there. That's not, just like any other way you send it securely.
It could be like a
It can
web.
be broken, anything you send.
No, I was thinking because you know how people will have their information, bank information, tamper with.
Mhm.
I was wondering, could the bank use the same method, but instead of it as taking information, but also if someone tries to take it, could also be the individual part of it.
Yeah,
As a
Yeah, you could do something, I'm not exactly, but you could use, and actually, if you look at some of the bankings and stuff, they actually use some other, not just like fingerprints, eye scans, et cetera, but you actually do use pictures to identify people with finger, that you have to identify that this picture is a picture, you know what it's off, okay? And as a way, so you can do some other stuff off of it. So you can go other places with it. So there's all kinds of things you could do. And obviously, if we wanted to make it secure, we would encrypt that message before we put it in there. that we would change it and put it in there, and then next meeting harder. Because then you pull a message out, that's not,
Put it in Gaelic or Apache or something.
or just encode it, or just encrypt it, run it through an encryption, and then stick that encrypted one in there. That then you got to decrypt that, but so you can make it more and more secure. But just remember, anything you do on there, of all of that, no matter how hard you try to encrypt, etc., or whatever, it can be broken. And no matter how hard you try to secure your house to make sure it can't be broken in, if you can still get into the house, somebody else can break that some way, however you've got, even if you've got 10 deadbolts on the front door. Okay? They have to figure out how to get through that.
There was also an article of this group of individuals who did it. Well, individuals did an article about how now they're using lasers to enter certain houses that have smart face technology.
So there's all kinds of ways you can break it to get through. And that we can make that house secure or whatever. And then sometimes what you're doing to make it secure actually opens up a hole. The Ring doorbell being an example. It's really neat that we can check and see who walked up to our front door sitting in class right here. Okay? But that's also been broken. And where you've had people actually figure out how to then spy on you wherever you are using that.
Stalkers and.
Okay? All right, I will see y'all on Thursday. And then we're going to go through and convert numbers from one system to the other.
It's actually interesting you that Babylonian thing, because I have 3 kids that are half Iraqi, and I keep telling them when they can't find their shoes and socks, like their ancestors, or the cradle of civilization, could have all these huge, they were in front of all these different technological advances of their time, and you guys can't find your socks.
But the Babylonians were way ahead of their time.
Yeah.
Yeah, they made mechanical.
It was aliens.
They had like the first, I think Salahuddin actually had like the first medical facility, like a medical
Mhm.
hospital.
They actually did.
Yeah.
Because you had different ones and some things that they could do and stuff that was, in some cases, we're just catching up with you in some stuff. That
And
they
then like
saw.
microbiology, they were the first people that were like, wash your hands.